Okay, then I will just take it away. So this talk is doing DevOps right, trunk-based development, CICD, and IaC. And I'm not going to define any of the acronyms. That's a joke. I will cover all of the important acronyms in the talk. My name is Drake Lundstrom. I'm a senior software developer at Rogue Fitness. Just started there this week, which is why my bio is out of date in the website. And I've done a lot of work with cloud modernizations or app modernizations and cloud migrations. So I've taken enough of a dip into DevOps to introduce other developers to it, and personally of the opinion that you're not really a full stack developer until you can do the DevOps yourself to some degree, because modern apps are on the cloud, on other servers. And I really enjoy learning and teaching, which is why I am up here and why you will see me around if you scour the Columbus tech scene. So, first important question, what is operations? In a business context, operations are about the delivery of product to the customer. So if we had, I don't know, a Nintendo Switch, because we're all nerds here, there is the engineering team, there's a manufacturing team that actually makes the product, but operations is how does this Nintendo Switch get to the store, that you have somebody manning the cash register, that you even have a store. Because if you do not have an operations team, if you do not get the product to the customer's hands, it's kind of worthless. And the same thing is true for software. I'll let you in on a little known secret none of you have ever heard before. It turns out that the software developers write... Oh, am I having an issue? There you go. Okay, perfect. Sorry. I can't actually tell the difference, but I assume it's way better. So I'll let you in on a little known secret. The software that developers write when it's in production is actually not running on our development laptops. It's running on a different system. I know, big shocker, but if you don't have it on that system, if you don't have it on Azure, on your on-prem servers, on AWS, it doesn't really do much. It doesn't matter how good your code is if it doesn't actually get there. And that is why operations are so important. And that is where DevOps come in. Because DevOps is a philosophy combining development and operations. Because if one side is making the product and one side is building and delivering it, we have to work together. And that's really what it's about. And you're going to see these infinity-style loops over and over in the presentation, because a big part of this is about iteration. It is about completing a cycle, getting a feedback, doing it better the next time, and trying to make shorter, tighter cycles. And on top of that, it is, once again, it is all about collaboration between operations and development to reduce issues. So, why does this presentation exist? This presentation exists because DevOps is not actually prescriptive. It is a philosophy, it is a guiding idea, it is not a product, it is not one specific methodology, and the problem is that nobody really knows what it is. A bunch of places say they do DevOps. It's the same problem Agile have. Has anybody here been in a company that said, we do Agile and here's our 12-month plan? Yeah, and we do DevOps, and that means that we take our code and we put it in a new folder, and then that's our version controls folders, and then we put it in the cloud, so it's DevOps, right? Yeah, no, there is better and worse DevOps, and I'm here to talk a little bit about what makes better DevOps. Because if you do it right, you get that speed, that rapid delivery, that reliability, that scale, all the benefits the cloud promises only happen if you do it well. And if you do it poorly, you can literally tank the company. Hopefully you won't, not very common, but yeah, fun stories. So a lot of the stuff I'll be talking about is being drawn from the DevOps Research and Assessment called DORA, that they do a lot of really quality writing about what makes good DevOps. I'm drawing from other sources as well, but if you want a good intro, this is one. And actually, if you look in their technical capabilities, you will see trunk-based development, infrastructure as code, and continuous integration, continuous delivery in there. So let's start. Infrastructure as code. What does this mean? This means that your digital infrastructure, your virtual machines, your app gateways, your load balancers, everything else are written out programmatically. They are not deployed by clicking. They are not deployed by a command line. They are deployed by a pre-made template. Very clear. And when I say manually, I mean clicking and pointing. I don't mean actually somebody went and carried a server to the AWS office. An infrastructure as code now is considered pretty much across the board a best practice. How you explicitly do it is up for debate because there's a bunch of different options. Terraform is very popular because of the capabilities that it has, being multi-cloud and having a lot of other built-in things where we'll also automate things like bash scripts. I personally mostly write Bicep because it's easier to stand up, and I do mostly Azure, and this will be a very Azure-heavy presentation. AWS CloudFormation, there's a bunch of other ones, even things like Jenkins do a bit of CICD, bit of IaC. There's a lot of options out there. Just know this is a best practice. If you do not know about this, if you do not do it, it is something you should be looking into. Because similar to any other form of automation and programming, it has massive benefits. In the same way that we don't ask, grocery store clerks to handwrite receipts, we should not be asking people to manually deploy hundreds of VMs with complex configurations. IaC reduces human error. It allows for faster deployment. It allows for near perfect repeatability. I say perfect, but it's programming. Sometimes there's a bug and you hit it and restart it. And it also allows for you to roll things back. So if you made an issue, something goes wrong, you can actually go back to a previous system. And then, of course, scalability. At some point, you will run out of operations times to click and point. You do not run out of computer times. They can just run while you sleep. And then it creates this change record of how things have improved over time. I will be covering this again. Don't worry. This is like a big slide. So this is the sample app that I will be covering throughout this presentation. It is a database on Azure. Everything I do is on Azure. And then there is a function app that is my API. It is a C# function app. For it to hit the database, it gets a connection string from a key vault, a secret manager on Azure, which then has identity and access set up for it to be able to do that. And on top of that, I have a front-end app service, which is just a web app that hits the API, hits the database. Very complicated, not really. Just so you know what you're looking at later on. And only this part I'm actually covering in the infrastructure as code for this. It's not uncommon for something like a database that's going to exist for a long time to be set up in advance and not edited by your day-to-day IaC. So here is actually what it looks like to have infrastructure as code. This is the app service. This is the front-end application. So you will see it has a service plan that is your server allocation. You put a name for it, and then you say your pricing tier. I picked F1. F is for free because I'm not paying for what I'm making for demos. Runs on Windows. And then I have the actual app service. It has the name of the site, which is passed in as a variable. Variabilize things impossible, make things modular. It references the server farm that it's running on, and then I'm actually able to insert some of my settings in there. So I actually put a secret in there to access the key vault and get the API key programmatically. And then I gave it an identity so that I can then assign roles to it. This is what is actually going on behind the scenes on cloud providers. When you click and point, they are actually writing things like this and sending them to APIs. And this is the entirety of the IaC that I've written for this application. Just so you're aware, this is about how much it takes to write those 4 resources, 3 resources and configurations. So why is this important? It is all about Toil. Toil is a concept in DevOps that refers to manual repetitive work that is devoid of enduring value and that scales linearly. What does that mean? It is the difference between putting out fires and fixing the gas leak. Toil is work that solves a near-term problem but does not move the ball forward. If instead of toil, you invest in automating and improving systems, you don't just solve the problem today, but you solve the problem next week, next month, next year. If you are doing things manually, as your organization grows, there will be more and more manual work to do. If you are automating systems, this system is automated forever, well, until you do updates, but it's essentially forever, and you have reduced future work. So this is actually a video demo of myself pretending to be both. ClickOps is a affectionate, aka derogatory, term for people that manually deploy resources, and infrastructure as code is on the right. So you will see these are two resource groups on Azure. They are both empty. They have nothing in them. And this video is sped up 5 times, so you don't have to wait through everything that I do. I'm not the best clicker. So let's go. So on the right, I went to application, ran it from the command line. On the left, I am going as fast as I can. Site's loading, setting up the API on the back end. I copy-pasted all the names. Normally, people make a lot of typos in the names. Another reason to not do ClickOps, because typos suck. Especially when it takes 10 minutes to provision a resource, and then you have to notice the typo, have to go back and forth. Not fun. Oh wait, the bicep is already done. Oh, that was fast. Oops, sorry. Yeah, turns out that when you do infrastructure as code, the application can run everything in parallel as efficiently as possible, so it is way faster than you will ever be. I think that's also, I just made a mistake, it wasn't on purpose, where I used the wrong application insights for the web app. It's fine, ignore it. Yeah, I'm still going, okay. Wow, I hope I have enough time in the presentation. Okay, the key vault's up, great. Oh, now I have to go in and actually configure all of my resources, because when you do it manually, you have to configure them after. If you do it in IaC, you can configure them at the start. So that's fun. Copy paste again. If you were doing it manually, you'd have no chance. Like, I already made typos and I was doing it with copy paste. Yeah, we're still going. Man, I don't know why people do this still. I'm relatively slow at this. I'm sure you can get the 10 minutes I spent down doing this, probably down to like 5 or 6, but I mean, it took 1 for the infrastructure as code. So now I believe that I'm assigning the security permissions for the app when I find it. It is really bad watching yourself do demos. I would not recommend it. So now I'm having to go in and add the role assignments, which is when I find that I made another mistake, which is that I did not actually make sure that my resources had their identities managed by Azure. So I can't even assign the roles. So I should have done 10x, honestly. I was debating if I'd have enough time to talk over it if I did, and apparently I would have. So now going back, finally, I have the identity set up right. I can select them, go through and do it. 1 more to go, and boom. You're all supposed to applaud now. That was amazing. Yeah, you can see why I'm kind of done doing ClickOps. And I'll be honest, the IaC probably took me an hour to write because I don't write it that often and I had to debug a lot. But here's the difference. When I debug my IaC and I fix it, it stays debugged. When I debug my ClickOps, I have to do it every time. And that brings us back to version control. Infrastructure as code means that we can perfectly reproduce what we've done in the past, and we can trace what happened. If the new version of the app has issues, we can see where that came from. We can even see who committed it, who approved it, all the standard things you get in Git and everything else. On top of that is disaster recovery. So let's say that your application goes down at 2 a.m. because you're an international company. Who here is willing to log on at 2 a.m. and deploy 20 virtual machines and thinks they'll do it right? Wow, no, okay, I was expecting more hands, but okay. Yeah, no, the computer can do it for you. You want to automate, okay, we have at least one hand. The computer can do it for you. It will do it automatically when things go down. You can also roll back to a previous version, same thing as the rest of Git. It is auditable. You can even do things like set up security permissions where your developers cannot actually deploy at all to Azure except through the pipeline. What does that mean? That means that you cannot have a junior dev accidentally drop the database because they can't even access the database except through a peer-reviewed piece of infrastructure as code. This is amazing. I promise. You're all like, I'm screaming internally. You're all like, oh yeah, I get it. No, trust me. You do not want to try to recover accidentally misdeployed cloud resources. If you leave, I don't know, an app gateway running for like a weekend, you can spend like $300 on accident. Not saying I've been there, but I have. It was fine. And then higher quality. Anything that you are able to iteratively improve will have higher quality overall. Next, we come to CICD, which stands for continuous integration, then continuous delivery or deployment. For some reason, they are both the D in CICD, which is a little confusing. It's fine. You again see the pretty loopy loop. That means this is about iterable improvement. So, continuous integration, continuous delivery are a culture and process around continually integrating new code. Think DevOps again. This is a cultural artifact. It is not actually an explicit system of practices, although it has become much more of one over time with CI/CD pipelines being the standard way to do it. Continuous integration means that when you commit code, when you have finished something, it is built and you actually try to put it in the real environment and resolve integration issues. Does this app actually work in the cloud? Because it turns out that you have a bunch of weird settings in your personal laptop the cloud doesn't have. So let's resolve those integration, those deployment, those bugs early, instead of trying to resolve them the day before release. Sounds pretty obvious. That is why this is a growing thing. Like I believe DevOps originally started in 2007, and it is now a mainstay across the industry. Continuous delivery, continuous deployment is a little different. So this is saying that you automatically progress. So continuous delivery says that at any point you can take your application and it could be deployed to prod. So it is ready to be delivered to a customer at any step along the way. It is not necessarily going to do a good job, but you could. Continuous deployment is that it actually automatically is. So this is actually advancing it to the next environment through pipelines with test and validation to make sure things are working properly. So automating more of those steps on. There are more extreme companies out there where literally every single PR directly deploys all the way out to production. That seems like a lot to me, but I'm happy for it to automatically deploy to dev and then to QA and maybe kind of stop and wait there. To each their own, but actually deploying it automatically to production has many benefits. For example, scaring developers into really checking their code well, because are you going to PR better? Are you going to better review a PR if you know what ends up in dev or if it ends up in prod? We all know the answer. This all revolves around Gall's law. So Gall's law is a law of system design, which goes, and I will read the quote verbatim, "A complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a working, simple system." What this means is that you cannot build all of Facebook tomorrow and hope that it works all in one go. Instead, first you build a login, and then you build a profile page, then you build commenting, you build piece by piece, and each individual piece that you add on has to work. And there's a really simple way to test this. So assume most of the room here is developers. So on Monday, or whenever you get back to work, if you have a long weekend, just go in, sit down, get your coffee, start coding, and don't run anything until the end of the day when you log off 8 hours later. And If everything runs perfectly the first time with no bugs, you might have disproved Gauss' law. Yeah, none of you are going to do that. You're going to run your code often. You are going to iterate and see what happens because it is much simpler to debug 50 lines of code than 5,000 lines of code. You find what works, add a working piece to it, and move on iteratively. And I think this is a really solid image explaining continuous delivery. If we were working physical parts and the first time we tested the wheels with the engine was the week that we're going to actually deliver the finished car, yeah, that'd be insane. That would be a joke. That is not how it works. Instead, you test parts piece by piece and add on to it. So first, do the wheels work? Do the axles work? Next, can we add steering? Can we add propulsion? Can we add an engine? Can we have a finished car? You actually build, you start with an MVP or even like a pre-MVP, just a minimal product, and add on to it bit by bit. And this allows for you to resolve so many of the errors early on in the process because the errors don't come just from individual components, they come from integrating components with each other. And the other benefit that you get with this is that you actually get to review each of these iterations with product owners. So here is a CI/CD pipeline. They're generally written in YAML. This one is for GitHub Actions, but you will also find them in Azure DevOps, GitLab, Jenkins, many other sources. And what it does is actually go through this one. It has a name up top, which is deploy infra, an app using GitHub functions. Very complicated name. So I'll walk through it bit by bit. So line 2 through 7, that says when this pipeline runs. On workflow dispatch means when you click it. On push branches main means every time there is a commit to main, this pipeline runs. You can do a lot of configurations here, and for example, have it only run if certain things are edited, or if other pipelines have run, or pipelines interconnect. But this one is very simple. Next, we're going to say the environment that it runs on, so that is actually the version. Then comes the jobs, and this is where you break up into your broader steps. In this one, I just have a simple one. So this job is to build infrastructure. The name is build infrastructure. It runs on Linux, so I'm using Ubuntu latest as the image. First step, check out the code. That pulls the code in the pipeline. Next step, lines 18 through 20, log into Azure using the secrets in using the secrets in GitHub. What does that mean? That you don't need to even give developers access to the secrets. So you could have somebody that joins the project, you give them minimal necessary access, the principal of least access, and they can only deploy things through this pipeline. Then actually building the infrastructure, that is a GitHub action that runs bicep based off the file main.bicep in the infra folder. So this is a fairly simple pipeline. It actually continues on for a few more steps, but this one will build your infrastructure. So now I'm going to actually run through a pipeline and show piece by piece kind of how it works. So this is building that overall app that I showed you earlier, and on the right is the resource group, on the left is the code. So first, you see there is actually nothing currently in the resource group. It is totally empty. I am starting from scratch. And I am going to add, commit, pull, push, which will start the pipeline. Yes, you can use the UI for GitHub. I like command lines. I'm weird. UIs have lots of benefits, but I like command lines. Okay, perfect. And I am pushing the app in a second. I also meant to turn my audio off for this recording, but I guess you can still hear me clicking. Okay, so that is the app that will eventually deploy. You will notice there is nothing there right now. And then when I actually go into GitHub, you can see the progress of this over time. You can even check the progress of previous runs, how they worked, if everything worked properly, when you go under actions in the repo, or when you go into a similar pipeline type in any other service for this. So my first thing is I'm validating the Azure credentials, then I'm building infrastructure, building the React app, deploying the React app, and then I actually had to deploy and build the C# app all in one go. Probably should have broken it up, but I decided not to. So that's the first step, and I am skipping ahead because these take a while. So next, the infrastructure has been built. You can see on the right there are actually things in the resource group now, same way when I ran the bicep, except it ran in a pipeline, which is great because if I reboot my computer, the pipeline keeps running. Now, when I refresh that web page, I have an empty Azure app. And you will notice there was actually a change to one of the URLs because I had an issue with some naming stuff. Everything else is recorded in one go. The first part had to be re-recorded. And that is the next step. Infrastructure has been built. Then the React app is being built and deployed. Those ones are very fast pipelines. React is pretty lightweight. And when I refresh it, boom, I have an app. It is lovely. It is beautiful. Graphic design is my passion. And I click on it, and nothing happens because the backend API is not yet up. Finally, the 5-minute final step in this pipeline ran, and when I refresh, let's see, I refresh that just to make sure it's all up to date, then you can also go in and click into the pipelines and see the sub-steps. Now, refresh the app, click on it, and give it a sec. Hope you had fun at Star Trek. Woo! It's an app. It was deployed all the way through. It is on the cloud. Anybody can interact with and use it. I did tear it down afterwards because the code in it was really ugly and I wrote this in a hurry. It's fine. It's a demo. You've all seen how this works. And now every single time I commit a change, I don't know, make the picture smaller, make it bigger, whatever else. If I committed that to main, it would update the front-end application within 5 to 10 minutes. And that's really the power of CICD. And normally you'd have more checks on the way, you'd put it in a dev environment first, but this kind of shows you the possibilities of how much time you save. Because it took me an hour to write the IaC, longer to write and test the CICD pipelines, but how long does every individual deploy take your team? And if it takes your team, I don't know, 20, 30 minutes, you're pretty fast. Well, we've cut it to 5, 10 minutes, and you don't even have to pay attention during it. So over how many deploys will it take before this is saving your team massive amounts of time? And the keys to this is that we have to actually test that this dev environment is in a real environment. What does real mean? Because I don't want to break prod. Nobody wants to break prod. It means that our dev environment has to perfectly match production. If your dev and QA environment do not perfectly match production, they're kind of useless. Not totally, but they don't actually test your code. How do we get them to match? Infrastructure as code. If we have programmatically deployed infrastructure, so they are entirely in sync, we now have an accurate testing environment. Then we go through and automate the testing. So every time this happens, we are removing steps, removing works and developers, because if testing's not automated, people don't do it. You want to automate and improve this process so it is being tested for you in the pipeline and in the cloud environment. And by doing that, we remove that toil and we move to, instead of making more and more work for ourselves, we have a compounding effect where we have better and better applications and infrastructure. And just to simple show you, and this is what happens when you actually have things set up right. If you did something wrong, I don't remember my issue in my React app. I think I had a string set up wrong. It will actually stop the pipeline. If you were gonna break prod, you don't, because the pipeline will stop you. If you are manually dragging over packages, you can drop as broken a package as you want in prod. It doesn't even have to build and you can put it in prod. If you're doing pipelines, that can't happen if it's written well. And this is a really solid quote from continuousdelivery.com, kind of something of one of the big ethoses of the philosophy. Bear in mind, continuous delivery is not magic. It's about constant discipline of pursuing higher performance by following the heuristic. If it hurts, do it more often and bring the pain forward. What this means is that if there is something important, and it's really difficult and painful, people avoid it, and it becomes this big monster, this big boogeyman in the background. When you deploy twice a year and there's like 2 weeks spent resolving issues, people avoid deploying. But deploying is actually really important. And instead, if something is important, you do it more often. And as you do it, you will resolve the pain and wear down that friction. It's like if you're walking through the woods. There is no trail in the beginning, but enough people walk through the woods in the same way, they will actually make a trail. If you are able to do the important things often and focus on improving and iterating and have a retro and say, what went wrong? What can we do better? You will eventually make your deployment process smoother and easier and better. And what happens then is when you're not spending all of your time putting out tiny fires and redoing manual tasks, you can now do more complex, innovative things. Because operations is not just important, it is difficult, it is complicated. There are a lot of things that you can do. You can make pipelines that have automatic blue-green tests where we'll put out a new version of the app versus an old version. You can have pipelines that, send an email to the QA team that your apps are all in QA and ready to test. You can have it deployed to multiple different environments and test in them. You can do a bunch of amazing things if you free up and remove that toil so that people doing operations, whether they are developers or in operations, have the space to do cool, new, innovative things. Like if your developer team is spending 50% of their time manually fixing data in your SQL database, they can't really write new features. There are new features in operations. People don't really think about that, but there are, and we need to give space for them to happen. So, where developers come in. I've been talking about DevOps, but it's in mostly ops, right? So developers come in because in the exact same idea, operations is kind of useless without a product to deliver it. It doesn't matter how pretty your VM is set up. If there's nothing in it, nobody really cares. So let's talk about how to put out quality code with the operations team. So a thing that is growing popularity is being pushed for by the people that push for good DevOps is called trunk-based development. And this is a development philosophy with short-lived branches that merge directly into main or master. That instead of, a long-lived feature branch for 3 months that then has a sub-branch for an error fix and all these things, everything is staying close to the trunk and coming back in very frequently. So top left, feature branches, you have, let's say you wanted to add video streaming. So you have a long-term branch for that, but somebody wants to make it mobile-friendly to make another long-term branch for weeks or months, and all these things are going on. Where trunk-based development means that you have a little bit, that constant small cycle iteration. Trunk-based development results in small stories. I keep saying that, but it's very important, so I will keep saying it. Low WIP. If you need to merge it in every day, you just can't have that many things in progress at once. You will actually be being more agile, having only 1 or 2 things in progress at once, limiting the branches, and then PRs will become fast because you will have to remove the friction or you will be buried under the weight of them. Feature branches, you have those large stories. You have sometimes I'm working on 1 thing at once, sometimes I'm working on 10 because I was working on this new feature for a while, but now this is more important, now this is more important, and all these things are left kind of half done. If your feature only takes, or each story only takes 4-8 hours, you're never going to leave it half done because you can just finish it up and go on to something else. And then the branches live for a very long time, and when they come back together, it's a bit of a nightmare. So let me give you a more realistic picture of feature branch development. So we're trying to make the app faster. It's been out for a while. Oh, there's a bug fix in main. We got to propagate up. Then we got to propagate that down somewhere else. The feature's been around. Now we have to share the feature of other things. It is a nightmare. The last client I was on, working with a lot of different teams of developers, so we didn't really have a say in how DevOps happened. But we have been working on redoing a big section of the front end for maybe 2 or 3 months of this long-lived feature branch. But turns out a different team was redoing all of the front end components. So about 2.5 months into our rebuild of the front end, we had to pull in all their components. And the two most senior people on a 5-person team were out of commission for about a week and a half dealing with merge conflicts. And I think when your senior developers are all gone dealing with merge conflicts, development speed and quality really goes up. Sorry, my sarcasm is really dry. I promise that was a joke. And the people that really suffer from this are actually often junior developers, because these large, complex things are very hard for them to grasp, where if you're building things small piece by small piece, they can actually follow along and help out. A junior dev can't really contribute to a PR of 50 files. They can contribute to a PR of 1 file. And then after this, I have a really cool image. I think it really captures the essence of trunk-based development. You've probably never seen it before. I'm really happy I found it. Yeah, I said very dry humor. Trunk-based development is CICD for developers. In the same way that you cannot try to put the finished app in the cloud for the first time the week before release, you should not try to first add these new components into the new UI the week before release. You should actually be coming together and putting pieces on top of each other as things go along. And if there are too many moving parts in one area for you to merge them all together, that's a sign something bigger is broken. That is not a bug of the process, that is a feature. Because you can have too many cooks in the kitchen in development, and what that results in is merge issues and code freezes. Instead, if you keep things to small, isolated stories, you can do this. And what this will look like is not just that, we're adding a new menu, we're adding a new color, we're adding all these new pizzas bit by bit, but that each of these we can actually take and show to the product owner. And we can prove to the product owner that we're actually writing things, because they don't always know. Sometimes they're like, what are you guys off there doing? Just like spinning in your chairs and sword fighting? No, we can actually show them each iterative version of the application, and they can provide feedback. Because the other issue you run into is that every single development and technology decision is first and foremost a business decision. If people are not on board with using and paying money for your product, it doesn't really do anything. It's kind of worthless. You need to have business on board. And if you take a set of specifications and go off on your own and build for 8 months and bring it back, how many people have done that and had their customer be satisfied at the end and have no feedback and changing things after 8 months developing on their own? Okay, I heard one snort and I saw no hands, so I'll take that answer. If we can iteratively take this product, put it in a dev environment, and put it on the product owner's computer so they can mess with it, we will get better feedback faster, because it's really easy to change things when there's not that much to change. And we will have not just more reliable apps, we will not just have faster made apps, we will have apps that actually meet the customer needs better. And this will, again, remove friction. By doing PRs over and over, you will learn how to do them fast. If you have to build and deploy every day, you will have to actually make your build and deploys faster. There's a really good talk on containers earlier about how to do that. And you will also make a lightweight review process. You will have to automate testing, because if you're trying to PR every day and deploy every day, and your testing and pipelines aren't automated, it just won't happen. And by trying to achieve this, you will improve your other processes. Another big part of this is PRs. So on the right is a pretty standard feature branch PR. It has 20,000 lines of changes. I'm sure a lot of people in the audience have seen at least a couple of these. On the left is 200 lines of changes. Who here thinks that they can read a 20,000 PR and catch pretty much all the bugs most of the time? Okay. Who here thinks they can read a 200-line PR and catch most of the bugs most of the time? Okay, more hands going up, but you guys apparently are not really confident about your ability to do PRs. Might need to work on that. But when you have a smaller PR, you can actually read line by line, catch all the things, you will have better code. And the reason this is so important to have more PRs is because PRs are incredibly important. They are one of the most important things that developers do because one, it teaches other developers. It teaches them what your standards are. It teaches them how to improve their code. Two, it is refactoring. You are refactoring while you are writing the code. And you know what developers don't get? Time to refactor later. And if PRs are the majority of the refactoring you're doing, and you're skipping them because they're painful and it's hard to schedule people, that is a problem. You need to have more PRs, not less, because they are important. And when you have more of an important thing, you figure out how to do it more smoothly. Another big part of this I hear a lot, so I'm going to now argue with all the complaints I hear from developers because that is mostly what I do, so I hear more of your complaints than I do from DevOps people. Reliability, that's a big question. Hey, every time we merge to production, we have all these bugs, we have all these issues, and you're saying you want to do it 10 times as much? Like, are you crazy? Here's the thing, a small PR is easy to fix. If we add, I don't know, a whole entire new feature on the site, we're gonna add video streaming to Facebook. It's really hard to roll that back because it's a massive feature and it's gonna have some bugs in it. If we're just adding one small new menu at a time, it's really easy to roll that back. No one even notices. So if you have bugs, it's easy to go back and fix them. And on top of that, with trunk-based development and CICD, bugs are the top priority. Always keep the pipeline green. If you are breaking other code, it does not matter how good your new features are, because if the app doesn't work, you don't have any features. So it's really important to focus on reliability. And also the data really bears this out. So once again, the DORA research, when they go through this, they actually track when you have developer teams that take different amounts of time to deploy features, what is their reliability, what is their speed of bug resolution. So teams that take weeks to months from getting a feature to deploying it versus teams that take 4 to 8 hours from getting a feature to deploying it. The teams that take less time do these very quick, very frequent pushes, they have a much lower error rate. I believe the number is 5% versus 15, but I need to double check the stats for that. But they also have a much faster bug fix rate. You can fix the bug in hours or days. I've been there. I have pushed more than a few bugs to dev myself. And when it is a small trunk-based branch, I can push a bug at 10 a.m., get told about it, and fix it by lunch. And it's a lot easier to fix it when you only have 100 lines of code to check for bugs. When you have these teams that have these infrequent, quarterly, half a year, big deployments, it takes weeks, months, or bugs just never even get fixed. So you actually get more reliability by deploying more often. And then, of course, because deploying more often forces you to automate and systematize your testing. Another question I get is how, okay, sure, this sounds great, but the thing we're writing is just too complex to do these small branches with. So a couple answers. One, there are exceptions to this. If you're doing setup, sometimes you just need to have like a senior architect and DevOps person sit down for like a week and set up the initial framework. That's fine. A couple of exceptions make sense. This is not an absolute rule. It is a general framework. With that said, if you're adding a new feature and you feel that it's too complex to break down into chunks, that normally is more of a question of your current understanding of the feature. Instead, you should do things like spikes that help you like essentially make a prototype of the feature, see what does and doesn't work. You can work on that for a couple weeks straight, but then you throw out that code or keep it as reference and rewrite it to be smaller chunks that you add piece by piece, as well as using other various strategies. We can go more into those in the Q&A if people have questions. Another big question, we just wait around with PRs, because you know right now when I try to get my team lead to check my PR, it takes about 6 hours, 12 hours, a couple weeks. Not actually, but like it takes a while. So do we just sit around and wait because we should never have more than 2 stories going at once and we're putting PRs through every day? The answer is, this is not a solo process. Everything I've talked about is about collaboration. It is a team effort. You cannot do this on your own. DevOps, all of it, but especially trunk-based development and CICD, requires a bit of buy-in. You can start on your own to demonstrate what things look like, but the team needs to be on board, preferably even coming a bit from the top down, having a larger group on board. And then you change the culture. You get people to agree that PRs are a top priority. They should be willing to put down their code, not like right now, but in 30 minutes to do a synchronous PR review. And that over time, what you will do is you will train more people to do PRs, because a junior developer really can't do a good PR of 20,000 lines of code, but they can actually do a pretty decent review of 200 lines of code, especially after they've been involved for a few months in the project. Another big thing is actually having good tickets. If your tickets and tasks are bad enough and every single one takes you multiple weeks or months to do, you're kind of stuck. And I say tickets or tasks because everybody uses different words and it's very confusing. So clear acceptance criteria. If you keep changing the goalpost, you cannot resolve things quickly because communication takes a while. On top of that, going back to continuous delivery, try to have vertical slices. This should be a completed testable unit of work whenever possible. That will really increase your, it's about integration again. So the last project I was on, it had some issues again, and they wanted the back end built first and then the front end. And you know what? Every single time the front end started connecting to an API for the first time, and I had these beautiful, fully reviewed back end APIs, turns out there was an issue where things weren't integrated properly, and every time we had to go back and change the back end API, every time. You will not find all of your problems until you fully integrate the system, because the parts cannot work, do not just work alone, they need to also work together. And then on top of that, having a single source of truth for what is and isn't the right way to do things. Another big thing I'm a fan of is having actual development flow, so knowing how you go through and write code. So this is my personal one. Feel free to steal it. Feel free to steal anything that I put out there. Take your ticket, clarify if needed, actually do the stuff on the boards that people don't like to do. It's really important from like a team perspective to communicate, especially when you have a lot of small tickets going on at once. Write the code and resolve it, but then actually check it yourself. Actually run it locally, check for typos and bugs, put it in an environment and test it there, and then go through your PR line by line and make sure there are no typos, there are no obvious bugs. There's a lot of reasons for this. One of the big ones is that when you're reviewing by yourself, you're using one person's time. When you're reviewing during a PR, using like 3 or 4 people's time, often a person that's more senior and busy than you. This is really a question of respect. If you are asking people to improve your code, you should be willing to look at it and improve it first. And we all have some bad days and skips sometimes, but your average, your standard should be that you have fully reviewed your code before putting it up. Especially, it makes you look smarter, it shows respect to the people you're asking to review your code, and then will also help you improve if you understand and catch your own bugs. And then, of course, submit it, review it, iterate over and over again. If I had to give a different title to this talk, if it was just about trunk-based development and CI/CD, it would be Don't Merge Breaking Code. I know you're all sick of it at this point, but I will say it again, that is the key. You really want to keep things green. It is all about reliability. And all these things work together. So we have trunk-based development. That means that we write small, vertically sliced stories. Each one adds a little bit of this new feature. Then the IaC pipeline automatically tests it in a cloud environment and integrates it. And that means that we are now able to know whether or not it works, whether it will work in prod, whether it will break anything. So we have now validated the quality of our code and can hand it off to the product owner to see if it's what they want. But how does the CI/CD pipeline work? It only works if the dev environment matches the prod environment. So how do we do that? We need infrastructure as code. So all of these things work together in an iterative system to mean that you will essentially never need to break prod again. You will be able to push out little bits of code that are well validated, that run in a real cloud environment, and push them to prod confidently. You will not need to stay up until midnight fixing these issues. And that's it. Everything changed and DevOps is implemented. It is the standard. This came out in 2007, and now every single hyperscaler, every cloud provider, every cloud service, if you go on the website, they talk about DevOps. They say, this is how we do it. This is why we do it. They say, this is vital. This is important. It is the future. Dev and ops need to work together. It will look different in every organization, but that really is what's the key going forward. If you have questions, a bunch of good books out there. The Phoenix Project is a fun read. It's like a story of a traditional organization going through the pain of transitioning to a more DevOps style thing. Fair warning, the transition process is long, painful, and brutal, and things will get worse before they get better. This book is a really great story of that. Accelerate DevOps Handbook. That one is a really good look at kind of what makes a good versus bad DevOps. Same with the DevOps Report, or just the Dora.dev. Their website has really great articles broken down. We had a reading group at last company where we'd actually each week read 1 or 2 articles from it. Really solid time. Thank you all so much for being out here. This is my first Stir Trek, and I've had an amazing time. So yeah, thank you so much. And I think I have time for questions. Perfect.
We got one on Discord. It said, how should you handle DevOps for mobile apps since it requires app approvals and the user needs to download and update? Feels like a true CICD pipeline isn't really possible.
Okay, so the question was, how do you handle DevOps for mobile apps because users need to actually opt in and update? It's going to look a bit different in every situation. One option is actually something like, I forgot the framework now. There are a couple of frameworks for mobile apps where they're actually just pulling web components, I believe. Is it Swift? Is that what I'm thinking of? Where they actually pull in web React components and run them locally on a mobile app. So it looks like a mobile app, but it actually is constantly pulling from the website. Another one is that at this point, mobile apps users are accustomed to actually those small, frequent updates that happen overnight. So we can't do it perfectly. There will always be people that don't update and fall behind. But if you were going to say what is easier, when you click download on those little mobile updates, the ones that take 30 seconds get downloaded a lot. The ones that take 10 minutes because there's a big change don't really as much. Hope that answers the question. Any more? Fire away. Or reach it on Discord or LinkedIn later. I realized I did not put my LinkedIn in this slide. I should have after I saw the other presenters do it, but my name is up there, and I am the only Drake Lundstrom that exists. It's lonely. Thank you so much. I will be around.